Hi everyone. So in this video we are going to see the last section of backpropagation. In the previous videos we have seen both forward propagation and also a backward propagation, and we used a 3-layer neural network. We calculated the derivatives of the weights with respect to the loss function, and the neural network, as I mentioned, was a 3-layer neural network, which looks like something like this, which I'm going to draw. Excuse my drawing, please. Right, something like this. Completed. Let me draw. Let's just color it. So in this video we are going to see the just the gradient descent, the last part of our calculations. So just as a reminder, in the first section we saw the weights W1 and also B1. W1 was a tensor. I'm going to write the dimension later, and also the B1, and this were in the first layer 1, and in layer 2 we saw W2, which was also a tensor, and B2, which was also a tensor. In the last layer, this layer, we used W3 and B3, right, which were also tensors. Then we calculated y hat, our predictions, maybe our prediction. And the dimensions, as we saw, of W1 was f1 by f. B1 was 1 by f1. W2 had a dimension of f2 by f1. This was 1 by f2. This was 1 by f3. And W3 was f3 by f2. Right, and this is what we saw in the first video, and in the second video this is forward propagation FP. In the second video we saw backpropagation. In backpropagation, we calculated dW3 and also dB3, right? We also calculated dW2 and also dB2. We also calculated dW1 and dB1. So please, if you are new, you can just go back and watch the previous videos. And what we noticed in the second video was that dW3 had the same dimension with W3, so f3 by f2. Similarly, dB3 had the same dimension with B3, 1 by f3. So while doing backpropagation, make sure that the derivatives of the weights, the dimension of the derivatives of the weights match the dimension of the weights themselves. And this had a dimension of f2 by This is f1, f1. Similarly, 1 by f2, 1 by f1, 1 by f, right? And if we can remember the input, maybe let me draw the input here, had a dimension of bs by f, right? This is your input to the neural network. All right, so let's see gradient descent, how to compute the new weights, right? So I bet most of you maybe might already know the formula, but to calculate the new W1 of gradient descent, you say W1 minus W1 to be W1 minus alpha times dW1. Alpha is a hyperparameter. You can make it 0.01. And W2 is also going to be the new W2. Let's see, new W1, new W2, alpha minus alpha times dW2, and the new W3 minus alpha times dW3. All right, so similarly, the new B1 is going to be B1 minus alpha times B1. New B2 is going to be B2 minus alpha times B2. And new B3 is going to be B3 times DB1, DB2 and DB3, right? The derivatives, this one's DB3. Okay, so one thing to notice here is when you compute the new W1, the dimension is going to be the same as dimension of W1, 1 by f1, 1 by f1 by f. Similarly, the new W2 is going to be f2 by f1. The new W3 is going to be f3 by f2. This is also going to be 1 by f1, 1 by f2, and this is 1 by f3. Okay, so this is now we have completed the backpropagation. So we have seen the forward propagation of the neural network, the backpropagation, and also how to compute the new weights and biases. Thank you.